Okay, so I have a few students who have finally asked some questions. So one of the questions was about the Chebychev, and I don't even know about the spelling. But Chebychev has an interesting theory, and it contradicts, or not contradicts, but it challenges what we call the empirical rule, which is what the second pair of questions you're going to have on this question. Now what they do in the question, they state a mean, and they give you a standard deviation within the question. So let's say hypothetically for this example, they tell you that the mean is 100 and that the standard deviation is, let's go with 10. So the first step that I would take if I were you as a student is I would draw a line to represent the values of the normal distribution or of the Chebychev distribution. And I would start with the 100 in the middle, going up a deviation, this is 110. In the second deviation, this is 120, and in the third deviation, this is 130. On this side, opposite of the 100, we have the negative z-scores. So I'm going to subtract 10 to give me 90. And from the 90, I subtract another 10 to get 80. And from the 80, I subtract another 10 to get 70. And the subtractions and additions on this side, you're adding obviously plus 10, and on this side plus 10. And I'm adding another plus 10 here. And over here, it's the opposite. When I go this way, I'm subtracting 10 from the mean and continuing that pattern through all the values. What these values represent are the z-score positions for this particular model based on the numbers they gave us. So every time you have a question, you're going to have to look for the mean and for the standard deviation, and you're going to have to create this type of drawing or model. So again, going back to the z-scores, the mean itself is where the z-score is equal to 0. This is the first deviation on the positive side, second deviation on the positive side, third deviation on the positive side. On this side, you have z equals -1, z equals -2, and z equals -3. So what I like to do is, because the nature of your questions, you're going to have the first two questions are going to be Chebychev, and the next two questions are going to be empirical rule. So I always set up the template in such a manner for my students, so when I explain this, it's easier to follow. So according to Chebychev, Chebychev has a formula that reads 1 minus 1 over k squared. Okay, and k is basically the same as a z-score. So think of k equal to z-score. Now let's look at the 3, whether positive or negative. And if I do 1 minus 1 over 3 squared, this becomes 1 minus 1 over 9, which in essence is the fraction 8 over 9, which in essence is 0.8 repeating, which can be reduced to 89%. And this is why Chebychev says that between the first, the -3 and +3 standard deviations, you should have 89% of the data. For the second deviation, the 2's, the -2, +2, if I do 1 minus 1 over k squared, which in this case would be either plus or minus 2, I end up with 1 minus a fourth, which is the same thing as 0.75. And this is why Chebychev says between the second deviations, whether plus or minus, you have 75% of the data. Now I can tell you that in the midpoint between these two, you have the -2.5 on this side, and on this side you have the +2.5 for z-score, or for k value. And that these values, when you look at these two scores here, according to Chebychev, 84% of the data falls in between those two values. Now, if they give you a question relating to the 1.5, for example, okay, so if that's the case, and you have a 1.5, so you would do 1 minus 1 over 1.5 squared. All right, so we'll pull out our calculator. All right, and so what we're going to do is we're going to do 1 minus parentheses 1 divided by 1.5 squared divided by 1.5 squared, close parentheses, and you get about 56%. So we know for a fact now that somewhere in here, let's call this another color. Let's code this, let's go with the blue. Okay, so this area here, this is 1.5 and this is 1.5. So this area in here in the little light blue is about 56% of the data. So 56% of the data sits in the negative 1.5 to positive 1.5 z-score. In the event for Chebychev that they were to give you the percentage and they said to you something like 36%, and I've seen this question before, remember the formula is 1 minus 1 over k to the second power. And so if this is the case, then you have 1 minus 1 over k to the second power equal to 0.36. And so the first step is to subtract 1 on both sides. This leaves you, in this case, negative 1 over k squared is equal to 0.36 minus 1. Okay, and again, if we use our calculator, let's just use a regular calculator. I guess not. So, okay, so negative 1 plus 0.36, which is the same thing as the opposite of what I just said, is negative 0.64. Okay. So we have negative 1 over k squared is equal to negative 0.64. Remember, we would change these both as positive because they're both sides are negative, they both become positive. And I can technically just swap these out. So if I swap these out, I get 1 over 0.64 is equal to k squared, and therefore k is equal to the square root of 1 over 0.64. Okay, so let's go back to our calculator. So the square root of 1 divided by 0.64, close parentheses, puts us at 1.25. So that means that at 1.25, which is somewhere about here, I'm going to give you another color for that one. Let's go with this green right here. This is about the 1.25 mark. This would be the negative and plus of it as well. So this is positive 1.25. Okay? So that's the process you would use to solve if they were to give you the percentage and go in reverse. Most of the questions are not that difficult, but this is the one that kills most people in terms of time, the time buster. Okay, so let's go on to empirical rule. And let's see what we have here. Now I'm going to erase the space so we can at least see the empirical rule part without much trouble. And what I want you to notice in the empirical rule And so in empirical rule, we're going to look on the bottom side, and we're going to use the same color coding. So I'm going to go ahead and make this a fuchsia. And so according to empirical rule does not require a formula, and nor will you need a formula once I've done this with you. I could tell you that between the threes, this is known as 99.7% no questions asked. So the two scores between 99.7% is 70 and 130. In the 75 mark, or for Chebychev, is the equivalent of 95% for the empirical rule. And this is just a given, there's no question there. And the same thing applies to the 68%, which is between the -1, +1, 68%. There's no formulation required there. And by the way, nor do you have to work it out in Chebychev. I did it so you could see where it comes from. There is no real, there is a formula for this part, for the empirical rule, but it's really tedious and it's not really worth your time. Empirical rule is pretty straightforward. It's just going to ask you this information as such. And that's what you need to do for empirical rule, is start here. Start here by taking the mean and standard deviation and doing what you see me do, what you just saw me do here, which is basically to keep adding the standard deviation up each time, and over here start with the mean and subtract the same value each time. Okay, and so that should answer this part of the questions. Let me go on to another question on a separate video, and hopefully this has provided some clarity.